So in this video, we are going to talk about stacks. Let's get to it. Welcome back to a whole nother video, and this is going to go off of the holiday theme, and I'm super excited. We're talking about another advanced data type, and that is going to be about stacks. And if you really like the theme, and if you also have some suggestions about other themes for these times and other seasons and other themes that you have in mind, please leave a comment down below, and I'll take a look at those and see if we can implement them. So within the stacks itself, it is a advanced data structure. But what exactly is a stack? So stack itself is actually an advanced data type that is a collection of objects that are operated in a particular order. It is very similar to queues, but it's slightly different. We will actually take a look at the differences and the similarities of the stack and queues in a whole nother videos. But for now, for a stack, you just need to know that it is a collection of objects that are following a particular order. And the order does really matter inside of a particular stack. And the order it is I'm talking about is LIFO and FLIFO, or however it is you pronounce it. But what LIFO is that it's the last in, first out. So what that means is that whatever is the last element inside of the stack, it is also the first thing out. And then the first thing in is actually the last thing that is going to be there. And that is going to be what the ordering is. It will be the last in, first out, and then the first element inside of it will be the last out of there. And kind of think about it as a stack of presents. If you have a stack of presents, you're most likely going to be grabbing it from the top, and you are going down from there. So the first thing would be going to be from the top of it. That would be the first out. And the bottom thing would be the last item that we are grabbing. And then with that, there is a particular order, and it always follows this order. It's actually technically one order, but it goes by two names from here. So if you do need stuff ordered within this way, then you might most likely need a stack. So one of the reasons why we use stack is, again, with the organization in large amounts of data, very similar to a queue. And because of data, if we are dealing with a lot of data, we need to be a lot more organized with them, and also take a look at them at a higher level of thinking or a higher level of handling the particular data. And if the data itself really does need a particular order of the last one in, first one out, or the first one is the last out, then we would need a stack. So the order does matter. And if we're using the LIFO or FILO ordering, that means that we actually need to use a stack in the particular case. And it is a huge advantage of using a stack. Most of the time, if we want to have items that are going to be operated of like the most recent item that we need to operate on, that is another reason to use a stack as well. It's because of the ordering, we're able to use the most recent item, and we can manipulate or modify it from there. Now let's actually talk about some implementation. And this implementation, it really depends on the type of language, because not all languages are alike. In some languages, you're able to use a stack data type with a stack library or stack class. Or if it doesn't have it, you have to create a stack yourself. So in most cases, you may use an array, or you can use some other data types, like a tree data type or a linked list or a class. Then you're able to implement a stack itself. It's just the way you're implementing it does matter. And what it matters is the type of ordering that you are doing it in. So that is what you'll begin to see when you're working in a stack, as well as when you are implementing a stack with an array or other data types. So let's say that you are working in a language that has a stack data type, and you're able to use it by doing initializing the new stack with the .new. So with that, when you are instantiating the stack, you're able to set that to a variable. For this example, let's just pretend that we are loading up Santa's sleigh. And Santa is very picky because he wants to be organized, to have all the toys at a specific order. That way he could visit as many children as possible and be the most efficient as possible. And what his ordering system is that he will actually put all of the presents towards the bottom of the houses he will visit last, and then the first houses that he would visit will be put at the very top. And that is one of the reasons why a stack would work best in this particular case. So for Santa's sleigh, let's say that the person that has a bike actually is going to receive the bike a little bit later, and that will be like the next house. So that will be the first item within this stack. The other thing is that we have a individual doll, and that would be from the first house that we would need to get, and to give the gift to the doll for whoever it is the gift is for. So with this as a stack, once Santa has it at this particular way of doing things, Santa is then, when they come to the first house, he's able to pull out the first top item, and that will be the doll, and that will be the correct present for that person. And that is how you are going to be implementing it with the stack data type. Now let's say that you are inside of a array data type, and it actually works a very similar way. It's just the way that you're handling the stack is the exact same way of how we are handling it inside of this array. And when you are handling it inside of an array, you need to have the first element of the array to be inside of the array itself, and that will be the last one that we are going to be using. And then inside of the last element that we put inside of the array, that is the first element that we are taking out. And that would follow the correct ordering that you would need to create a stack within an array. And this goes the same way with other implementations too. It's making sure that the order that you are doing the stack follows the FOLO and LOFO ordering. So when we think about live examples of this, you can think about it in the real world. Like when we are having to put away the books, we are most likely going to put it at the top book away first instead of the bottom book, or else the books will topple over. Same with presents too. When you're opening a present, you're most likely going to open it from the top, which is the most recent one that you put on top of the stack. And when you're washing dishes, you are going to put away the dishes that you wash first, and then you move on to the next one. So the last one that you put in your dishwasher is actually the first dish that you used. And lastly, a last real life example is that when you are putting up the Christmas tree, in most cases, you're putting it from the bottom to the top. And when you're assembling a Christmas tree from the bottom to the top, after Christmas is done, you are then able to go ahead and use the Christmas tree and put it away from top to bottom. So the most recent piece of the tree that you put, which is the top of the tree, will then get left first because of the ordering of the stack. Now let's actually apply those into like a coding or like a technology standpoint. So if we are going to implement this in like a word processor or like inside of like an art project or something, we may have to do something like undo or redo. And that requires a stack. We need to have the latest version of the edit or the latest version of the word, and we need to store them within the stack. So that way, when they are undoing, then they are no longer doing the last thing. And if they're redoing, then they are redoing the last thing as well. So you're able to use a stack from that. So when we're doing like an undo, let's say that inside of our word processor, I drew a picture and then I accidentally erase a picture. I can undo that. And then within my stack, I can just get rid of the version of it is that I am erasing. So that is how you can use a stack to implement a redo and undo functionality. One of the most common things of how you would encounter stack is a stack trace. And essentially what a stack trace is sometimes you mostly see it with errors. but it allows you to see what code and lines are executed before it reaches that error or before it reaches that point of execution. And that's what a stack trace is that it traces all of the things that you did within the coding process. And within errors, this is really good to notice because it actually lists out what it executed first and all the way to the most recent execution. That way you can kind of take a look at stuff and kind of track down the code itself. And that really helps you out of how to kind of debug your code and also to go back into some versions of your code or go back to the order of execution and see where it is that it is messing up on. And with this example, you can always take a look at what is going on and what is executed within this certain place and time. And then with that, I'm able to kind of backtrack if I do have errors of what it is that I am doing and taking a look at how I can solve that error. And you can do this in almost every single language. Every single language should have a stack trace of what the order of execution is. So that is it for all I have for stacks. Again, just think about stacks as a real life stack of like a stack of presents. And that is the particular order of it is that you are doing. So that is the first in, last out, and the last in, first out. That is all I have. If you like this video, don't forget to hit the like button below and subscribe if you haven't already. And I will see you in the next video. See ya.